In the second video of step 14, we're going to talk a little bit about reflections and periods of our sine and cosine functions. So scrolling down to guided practice 2a, let's just practice again graphing first the parent function, just like we did in the last video, and then graphing the new function g of x after that. So I'm going to grab my pink to stay consistent so we know which one's which. F of x is cosine. Cosine does not go through the origin. It starts up here at 1, comes down to 0, -1, 0, back up to 1, 0, -1, 0, back up to 1. So connecting these as smoothly as possible with a nice cosine curve, we get our graph. Sine does go through the origin. Starts at 0, goes up to 1, back to 0, down to -1, up to 0, up to 1, 0, -1. And again, connecting these points, we have a sketch of our sine function. All right, so next we have to take into account the amplitude, which we can see right here. 1/5 is our amplitude. Over here, 4 is our amplitude. Just like your height can never be negative, even if you stand on your head, your height is still a positive number. Negative just has to do with the reflection of the graph. So we would normally go up 1/5, but it's negative. So the first thing we want to do is reflect over the x-axis. So it would actually be down here at -1, but we're not going as far as -1. We're only going -1/5. Then up to 0, up to 1/5, back to 0, down to 1/5, up to 0, up to 1/5, down to 0, down to 1/5. And you can see we get quite the flat cosine curve. That would be -1/5 cosine. I know it's cosine because it doesn't start at the origin. I know it's negative because it starts below the origin. So just looking at this graph, I could tell that it's a negative cosine graph. Over here for sine, again, we're probably going to need to add a little bit to our graph here, make it a little taller, because we see that amplitude of 4. So we're going to have to go as high as 4 and as low as -4. But it's negative. So notice that sine usually starts at the origin and goes up. But because it's negative, it's going to start at the origin and go down. And it's not just going to go down to 1, it's going to go all the way down to 4 because of its amplitude. Back to 0, up to 4, back to 0, down to 4. 0, 4, 0. So when we connect these, we have our sine graph that is -4 sine x. Okay, so next we need to talk a little bit about the period of a function, of a sine and cosine function. The period can be taken anywhere on the graph. It's just what part of it would we have to highlight? So if we could use it kind of as a stamp over and over and over, this would repeat over and over and over. That's what we're trying to do. Typically, a great way to find the period is to not just pick some random point on the curve, but I always tell people, pick something on the y-axis. In other words, if I were to draw a y-axis over here to the right on this picture, there's my y-axis, here's my x-axis right here. I like to think about it like people running at a track meet, like this is lane 1, this is lane 2, lane 3, lane 4, lane 5, 6, 7, and so on. I like to think about it that, okay, if I start right here in lane 1, but I start running and I kind of get a little disoriented and I dip down, how long before I get back into lane 1? That's kind of what we're trying to visualize here on these graphs. So, for instance, you can see right here, I'm going to point out, is lime green here. Here's my starting point. If I trace along my blue graph, I would have to keep tracing until I get all the way back up to 1, because these are at the same level. And then I look down, and that's my period. So the period of the cosine function is 2 pi, and then it repeats. But the period of cosine of x over 3 is not 2 pi. Notice, if I look at the red one, if I start here, I don't get back to that lane, back up to 1 until here, which means my period is 6 pi for this function. Now, there's an easy way to remember the period. We have a formula. It's right here. You're going to want to memorize this. It makes things very easy, very manageable. In order to find the period, you're just taking the coefficient of the x in your function. You're taking the absolute value of it, and you put it under 2 pi. That tells you your period. So for instance, if we go back and we just say the parent function here, y equals cosine of x, the coefficient of x is 1, the absolute value of 1 is 1, 2 pi over 1 is 2 pi, and that's the period of the cosine function right there. But if I have cosine of x over 3, that's the same thing as 1/3 x. Now I'm taking 2 pi over the absolute value of 1/3, which is the same thing as 2 pi divided by 1/3, which is the same thing as 2 pi times 3 over 1, which is 6 pi. So we can get our period from the functions, or we can get our period from the graph. So what does this mean? Well, we need to know the period and then sketch at least one period on the same coordinate axes. I'm going to pause the video and go ahead and just graph my parent functions first. This is probably the 3rd time you've seen me do this on the videos, so I trust that you know how to do this. Pause the video and just get the parent functions graphed. Okay, now we're ready to graph our g of x functions on the same coordinate axes. So again, if I take the coefficient of x right here, it's 1/2. I'm going to put the absolute value of 1/2 under 2 pi, which is the same thing as 2 pi divided by 1/2, or 2 pi times 2, which is 4 pi. What does that mean? Well, currently I start right here and I get back to lane 1 at 2 pi. But in this case, I'm not going to get back by 2 pi. I'm not going to get back up there until 4 pi, which means halfway through that, I'm not going to be at 1. I'm going to be at -1. Halfway through those 2 points, I'm going to be at 0. So you can see now, if I connect these points, I get my flattened cosine graph. You could also actually plug these values in and see what you're getting, because we know some of these numbers from our unit circle. That's another way to do it. Right here, I'm going to take my 2 pi and I'm going to divide by the absolute value of 3. So 2 pi over 3 is my period, which means I'm going to start here, and at 2/3 pi, I'm going to be done. I'm going to be back where I started, which means I need to get an up, down, back up fit by the time I get to here, 2/3 of the way to pi, because this is 1 pi. This is about 2/3 of the way there. I need to get all the way up, down, and back up in 2/3 of a pi That's my period. So it's been condensed, if you will. And you could repeat this over and over and over. The directions say just to graph at least one period on the coordinate axes. Let's try this next one. Cosine of 1/4, we're going to take 2 pi, put it over the absolute value of 1/4, which is 1/4. This is the same thing as 2 pi divided by 1/4, or 2 pi times 4, which is 8 pi. So you can see this is going to require stretching out our graph a bit, making it a little bit longer. There's 5 pi, 6 pi, 7 pi, and finally 8 pi. What this means is that we start here and we get back up to 1 right here, which means halfway between 0 and 8 pi, I will be at -1. Halfway between 0 and 4 pi, it's 2 pi, I'll be at 0. Halfway between 4 pi and 8 pi, 6 pi, I'll be at 0. Because remember, cosine starts up, hits 0, it goes down to -1, comes back up to 0. Got a little squirrely there. Let's try that again. Down to 0, down to -1, back up to 0, and back up to 1. And that would be one period of that function.